Hello everyone, welcome to our today's session. Gone are the days of exact matches, SQL joins. I would like to introduce today's speakers, myself Ramya Mohankumar. I am working as a freelance data scientist. Previously, I worked as a data analyst in Northern Ireland Water Belfast. I also worked as a technical support representative in IBM India Private Limited. I would like to introduce my co-speaker, Minu. Minu is working as a senior data scientist at Carrick Group Limited, Belfast. She has 11 years experience in the IT industry. Previously, she worked with Infosys Limited and RM Education. This is her second NI Development Conference talk. We both graduated from Queen's University, Belfast with MSc in Data Analytics. In this webinar, we will talk about SQL joins and we introduce fuzzy matches. Let us start with the problem statement. Consider the scenario where you are a government official and you have data about local businesses. Suppose you have a database with 3 tables which contains information about their sales, employees, and department. All 3 tables have a related column which represents the business entity. Task in hand is to get information about sales, employees, and department of a particular business. SQL joins is the traditional solution for this problem. You can perform actions on a database using SQL statements. SQL stands for Structured Query Language. A SQL join clause is used to combine rows from 2 or more tables based on a related column between them. Why do we need joins? To join 2 datasets or tables, to retrieve more information, to filter data, and to reduce duplicate records. What are the different types of SQL joins? In a join, it returns the records that have matching values in both tables. Left join, it returns all the records from the table and the matched records from the right table. And the right join will return all the records from the right table and the matched records from the left table. Full join returns all the records when there is a match in either left or right table. Now let's look at the sample database and tables associated with it. If we need information about Carrick, then highlighted data is what we are looking for. The SQL join statement will look like this. Now, the result from the SQL will be it was a fine journey so far. Now look at this scenario where there is a typo in the data in the sales table. For the same SQL, we will get only 2 rows instead of 3. Like this. Consider another similar scenario. Left-hand side entries represent the company Carrick, but written in different ways. How do we retrieve information then? Over to Minu to discuss fuzzy matches.
Thanks, Ramya. Hello, everyone. So let's see what fuzzy matching is. It is not about are string A and string B the same, but it is about how similar they are. Let's see some of the applications of fuzzy matching. Typos corrector, that is checking spelling mistakes. Identify duplicate records. Spam filtering. Record linkage or comparing records. These are few of the techniques in fuzzy matching, which is used in industry. Now look at some of the methods which we use in fuzzy matching. The most common one is edit distance method. which is used in smaller data sets or smaller tables. When you have large data sets or large databases, then we'll be going for the second method, which is TD-IDF method. So let's start with edit distance method. So edit distance is a way of quantifying how dissimilar two strings are to one another, and we'll be counting the minimum number of operations required to transform one string into another. The most commonly used edit string technique is Levenshtein distance. In Levenshtein distance, we have three different operations: removal, insertion, or substitution of a character in the string. Let's take a simple example here to calculate Levenshtein distance. We have two strings, kitten and sitting. Let's try to transform kitten to sitting. First, we substitute S for K. In the second operation, we substitute I for E. And in the third and the last operation, we'll be inserting G at the end. So, in three different steps, we are able to transform kitten into sitting. Hence, the Levenshtein distance will be 3. Now let's look at some of the Python implementation of Levenshtein distance. The first one is the library Levenshtein itself. So here we have two strings, carry group as string 1 and carry 2 with typo in string 2. And here we can see the Levenshtein distance is giving it as 2. So that means in 2 edits or 2 operations, string 1 can be converted into string 2. Now the string 2 is changed. So string 1 is again carry group, but string 2 we have given it as ABC. And here the distance we are getting is 10. So that means string 1 can be converted into ABC in 10 different operations. Let's look at another library which is commonly used and more popular, which is called as Fuzzy Wuzzy. In here we have different functions which will help us identify the Levenshtein distance. The first one is ratio. So ratio will be giving the standard Levenshtein distance similarity ratio between two strings. So here we can see like 85 is the ratio which we are getting. And also there is one more function which we can use, which is called as partial ratio. In here, it will be returning the similarity score of the shortest string. So basically we'll be finding the shortest string first, and then we'll try to see the similarity score of that string inside the second string. So we have carry group string 1 as the shortest. So that shortest string we'll be checking in string 2. So we are seeing like it's 100% there. In the previous example, string 1 was completely inside string 2. Now in this example, we have made a typo. So string 1 is not fully inside string 2. So we can see like even the partial ratio has reduced to 90 from 100. So far we have compared a string against another string. But in our case, what we have to do is we have to take a particular string and compare against different values. Or inside a column, we have to see whether that particular string is there or not. In that case, we'll be going for a function called extract in Fuzzy Wuzzy. So you'll give a string which you want to match. That is what you have in the second line. And then you'll give all the options which will be the column, the values in a particular column. So here and then what we do, we'll be calling extract function, and what it will give is, it will give us an output of all the strings which are similar with a amount of ratio. So in our case, what we have told is like we want to see the most similar ones. So here you can see like carry group, the first three are giving 95 percentage and the last two are 60 and 30. So when we introduce extract function, we can mention that we want to see only the highest ones. So these operations can be done on smaller data sets. But if you have larger data sets, which is a common scenario nowadays, if that is the case, fuzzy wuzzy or Levenshtein distance may not help us. That is when TD-IDF matches will come into picture, and it also provides more information about the distance and what are the different strings which we have compared that we can see. Also, we'll be doing a many to many comparison here instead of a string against many strings. So that's why TD-IDF matcher is a winner here. And you can see like there is a match confidence column here, which is nothing but a cosine distance between the matches which are normalized to 0 to 1, 1 being the highest. So this result shows 0.89 in Carrick. So that's the first row where you can see like lookup 1 and original name. So they are very close. In the second row, you can see the match confidence is 1 because YUT is the original name, and in our second string options also we have that YUT, the same exact string, so that's why the confidence is 1. So these are the two different methods which we wanted to share it with you guys. Thanks once again to everyone who has listened to our talk, and also a big thanks to NA Develop Conference. See you next year.
Thank you.